So, let's talk about Earth. We know about Earth. Earth is a very strange place to live. Most aliens trying to land anywhere on this planet would be startled to find that there is a surface of water. 70% of our surface is water. That means 70% of our surface is liquid. It is the only planet we know of that actually has liquid water. In fact, we've now looked at exoplanets and looked in the very far distance. There is very little liquid water. The one exception is the moon known as Europa, which has an ice crust, but if you break through that crust, you end up in a whole bunch of water. But for the most part, we can't find a lot of liquid water, so it's amazing that we have so much water. Second thing is this: our atmosphere is oxygen. Turns out, by happy circumstance for human beings, there was something called a stromatolite, a little tiny bugger, little tiny bacterium, sludge that grows on the side of rocks that So there's a little tiny sludge that appears on rocks, okay? And that little tiny sludge that appears on rocks, the goo, turned carbon dioxide and rock into oxygen. That was this byproduct. It was eating things, and it was basically eating rocks and turning it into air, oxygen, which oxygen, by the way, is very poisonous. We ended up with a huge extinction event, and we almost lost all the creatures on the planet, except for stromatolites, which like the oxygen. The good news is, hanging out in the ocean, some carbon dioxide existed, so things like plants and flowers and trees and things could eventually grow from that. They weren't there at the time. All of it was single-celled organisms sitting in the ocean. In fact, most of that stuff happens in the 500 million years right before now, but at the time, that oxygen was very bad. That oxygen had one very positive quality. At the very outmost of the atmosphere, there is a layer of something called ozone. Ozone is extraordinarily important. And for those of you who worry about environmental issues, the hole in the ozone was a real thing, and it was really, really important. At the upper top of the atmosphere, we have so little oxygen that oxygen, instead of being able to pair like it normally does, 2 to 2, you know, oxygen does this, it shares 2 bonds, and then everything else is pretty much like it normally does. And there's your oxygens, right, all happy. Instead, it builds structures of 3. Now, this is important because it shares 1 this way, shares 1 this way. Now, why does it do this again? Because oxygen's fairly rare up there, so it doesn't have enough time to form into 2s, and so it's very happy up there. So what happens is sunlight comes in, ultraviolet light, hits this and breaks apart, and so it sucks up the ultraviolet. Ultraviolet light is what gives you sunburns. The majority of it never reaches the surface. If we lose the ozone, we would actually have a really big problem. It would start microwaving a lot of the people on the planet. Now, it would not be a instant microwave. It'd be more like sunburn. But it'd be sunburn when you walk outside 5 minutes later, you got a sunburn. Not a great situation, especially because we need sunlight to survive. So therefore, this little thing, this little hole in the ozone would happen because of a chemical reaction. Hopefully, chemistry will tell you all about that someday. And that caused the oxygen to break apart. That oxygen breaking apart led to what we call a hole in the ozone, and some sunburned penguins and some things we really worried about. We figured out what the chemical was. We stopped making the chemical. We had to wait 30 years, and pretty much the hole in the ozone is starting to repair itself naturally. That's good news. So what's the current one we were about? The current one we were about is something called carbon dioxide. There was a guy in the 1980s who said, well, I drove my car here, and I'm puzzled because out of the back comes carbon dioxide. We just talked about Venus, didn't we? And if Venus, which is 90 whatever percent carbon dioxide, we're not that, but we have to be growing, right? Because we're burning stuff like crazy people. Therefore, there has to be an increase in carbon dioxide, which means there has to be an increase in warmth. And so he suggested this could be a problem. From that hypothesis, several people have extrapolated all sorts of dire scenarios. Those dire scenarios, for the most part, have not come true, but because the Earth has ways to modulate it. That does not mean that there's no chance of sudden, horrifying bad news. In fact, in the bottom of the Caribbean, the Gulf of Mexico as well, there's a huge amount of what's called calcium carbonate, which is trapped carbon dioxide in our ocean, saving us from all the carbon dioxide in the atmosphere. And that, by the way, when it gets warm, that carbon dioxide comes back out. So as we heat up the planet from having global warming, we might actually trigger more carbon dioxide being released, which would cause cascading effect, similar to a nuclear meltdown, and only in the sense that it would be continuing and make itself stronger as it goes on, and it would warm up the planet. Now, the good news for you, and the thing that scares me to say to people out loud, because people go, oh, we can fix this, let's get on this. There's a very easy way to solve a global warming problem. In fact, dangerously so. Right now, whenever a volcano goes off, our atmosphere changes about 15 degrees surface west. To give you perspective, it's currently believed by the people at the Department of Energy that we probably got about 1.8 degrees Fahrenheit above what we normally should have. That's warmth. It could be bad. Could be. It seems already small. 1.8 degrees. Who cares? I mean, that's not a big deal for a normal day. It could be a bad day if that causes it to go to 2, 3, 4, 5 really fast. Just keep in mind, anytime a volcano goes off, we get 15 degrees negative. In fact, we're going to want that warmth if we can pull it off. It is possible, even likely, that you could build a device which could put enough particles in the upper atmosphere to do this. Now, I would advise against it. So I'm hoping when you hear that, you hear the full sentence, which is we possibly could control global warming by putting a bunch of stuff in the upper atmosphere. But keep in mind, that could also trigger an ice age, and an ice age is a real thing, and it's a bad thing. The last time we had a major ice age, New York City, for example, was under 100 meters of ice. The whole entire city, which didn't exist at the time, obviously, was under 300 feet of ice, top to bottom. That's a big thing. That's an extinction level event the other way. So just be aware that there's possibilities, that human beings are incredibly clever when it comes to these sorts of things, and we possibly could deal with it. But that is why we believe there could be a global warming issue. In fact, it's logical to assume we are warming in some fashion or another, but so far the numbers aren't really bearing out a massive, it's time to put our hair on fire and start shooting up stuff and making fake volcanoes sort of situation. In fact, the Earth seems more resilient than we thought. And so there's some interesting things to figure out why it's so resilient. So other things that you know about planet Earth. That oxygen, it's extraordinarily corrosive. This is the most corrosive planet there is. And therefore, and our atmosphere, although it's not horrifyingly thick, probably kept us protected from asteroids coming in. And those asteroids probably, for the most part, didn't strike the surface. Now, we do believe that one large asteroid hit about 76 million years ago, struck the ground. To give you perspective, we think it killed the dinosaurs. Like, well, how can the rock kill dinosaurs? Well, keep in mind, the relative speed was about 30,000 meters per second, okay? That is 100 times faster than a bullet. You're talking about a mountain or something larger than a mountain coming down from the sky and striking the Earth at that speed. The effect is large. The calculations we make is as follows. It struck somewhere near the Gulf of Mexico. In fact, if you see the little leg hanging out, that is one edge of the crater. Okay, so if you imagine the peninsula out there, I'm not drawing well. Okay, here we go. It goes like this. The Gulf of Mexico looks like this. This right here is part of the crater that was made. We believe that pierced the ocean, got all the way to the bottom, slammed in the ground, and cracked the bottom. It would have sent all the water that was in that area up in the air as steam, cooling the planet for approximately a century, give or take. Now, the impact would have been significant. What do I mean by that? Remember, it hit near Mexico, right? So, for example, if you were standing up in New York City, hanging out, minding your own business, it would have snapped your leg. The shock wave would have snapped your legs. Snapped your legs. You stand there, snap your legs, you're on the ground. The wind, the good news is you probably wouldn't have been standing up because the wind coming through the air would have been traveling at supersonic speeds, which means it would have blown you around like you were a little tiny piece of paper at hundreds of miles an hour. And by the way, there would have been a really large tsunami. The current estimate that I read recently suggests that tsunami would have been close to the top of the Appalachian Mountains, which means if you were sitting in New York City, you'd have been under hundreds of feet of water. So at least your worries about, you get blown in the air, If you stood back up, your legs would get snapped off. Oh, by the way, this huge web of water comes over the top of you, you die from that. So you imagine dinosaurs had a rough day when it hit. They also had a rough day afterwards because, again, the planet would have cooled for a very, very long time. And we know that they ate quite a bit. We now know they're warm-blooded, so these things would have really bothered them and probably led to extinction. Although you should be aware, there's a little tiny thing called a mammal that was just basically came on the scene, and it was an egg eater, and it was brand new and is extraordinarily successful. We find much indication that your great-great-great-great-great-great-great-great-great-great-great-grandparents were busy eating dinosaur eggs. They were probably about 6 inches tall, lots of fur, and they were punching holes. They had big buck teeth. Those big buck teeth were used to punch holes in eggs. So that could have had something to do with the fact that dinosaurs didn't make it also. Because they are fairly prolific at this time. What else am I missing? What else do we need to talk about? Our day is a day. You know what a day is. You pretty much know the rest of you need to know about Earth. Our temperature variation is not great, but you know what the temperature will be roughly like. All right, that does it for Earth. Let's move on.